Welcome to The Long Run. This is a podcast for biotech adventurers. I'm your host, Luke Timmerman. Today's guest is Fred Appelbaum. Fred is a physician, scientist, and administrator. He's an executive vice president at the Fred Hutchinson Cancer Center in Seattle and a professor who has devoted his career to the research and treatment of patients with leukemias, lymphomas, and other cancers of the blood. He's a pioneer in the field of bone marrow transplantation and was the lead author of a 1978 paper in the journal Blood that heralded the first successful engraftment of autologous bone marrow in patients with malignant lymphoma. Fred didn't do this work all alone. He was inspired by someone, and he worked with others on a team. One of the key influences was E. Donald Thomas. Don Thomas won the Nobel Prize in 1990 for the discoveries that paved the way for bone marrow transplantation to become a common and life-saving procedure for people with blood malignancies and more. Thomas died in 2012. Fred thought there was a story here. Who was Don Thomas? What did he do? Why does it matter? And what did it mean for the future of medicine? This story needed to be told in book-length form or else risk being lost to the dustbin of history. Fred decided to take the story into his own hands. He's the author of a new book titled Living Medicine, Don Thomas, Marrow Transplantation and the Cell Therapy Revolution, published by Mayo Clinic Press. It's excellent. I had a chance to read an advanced copy, and I wrote a jacket blurb which called it a tour de force of medical science history. This book is easy to read and hard to put down. Anyone who wants to know about where breakthroughs come from and how medicine will change over the next 20 years should read it. Listeners should also know that I have channeled a lot of my philanthropic energy toward the Fred Hutch over the past 5 years, so I'm well aware of the story and fond of the institution. But I learned a lot from this book and came away believing strongly that listeners of this show, pioneers of biomedical innovation today, would benefit from reading this book. In this conversation, Fred discusses a bit of what's in the book, the process of researching and writing it, and a few things he learned along the way. Before we get started, if you like listening to The Long Run, you'll love a subscription to Timmerman Report. This is where you can read my in-depth reports on the most interesting startups in biotech, my regular Friday Front Points column that concisely covers the issues of the week, plus insightful coverage of current topics from a rotating cast of contributing writers. Individual subscriptions are available on a monthly, quarterly, or annual basis. Group subscriptions provide a license to companies that have more than one reader, and you can get a discount that way. Go to timmermanreport.com and click on subscribe for more. And for sponsorship opportunities on this podcast, or to inquire about bringing me to your company for a speaking engagement, see my business representative, Stephanie Barnes. Go to timmermanreport.com and hit contact. Now, please join me and Fred Appelbaum on The Long Run. Physician, scientist, administrator, and now author of Living Medicine, Fred Appelbaum. Welcome to The Long Run.
Thank you for having me, Luke.
So, Fred, I thought it would be good to start with the first sentence of your book. You say, even though I've been doing it for decades, every time I perform a bone marrow transplant, it seems like magic. Wow, that really grabbed me when reading the first draft. So can you elaborate on that, what you just said there? Maybe start by saying, what is a bone marrow transplant for those who maybe aren't super familiar, and why do you get that feeling?
Well, as you know, Luke, the blood system arises in the bone marrow. There's cells that are defined as stem cells that are responsible for eventually making all of our red cells, our white cells, our platelets, and forming our entire immune system. And the concept of bone marrow transplantation is that if you have an abnormal bone marrow, either because it's failing to produce normal cells, like in aplastic anemia, or produces abnormal red cells, like in sickle cell anemia, or it's malignant, like in leukemia, the concept is that you could wipe out this abnormal bone marrow and replace it with a normal one from a normal donor. What Don Thomas showed in the late 60s, early 70s that it was actually possible to treat a patient by giving them very high doses of chemotherapy or radiation therapy, wiping out their bone marrow, taking bone marrow cells from a normal donor, infusing them intravenously, and this is where the magic is, that these stem cells, you just infuse them intravenously and somehow they find their way to the bone marrow, they repopulate the bone marrow, and they start growing in this new host and forming normal red cells, white cells, and platelets in a regulated manner. That works is just, it's a miracle.
These are cures.
These are cures. These are cures of people that have otherwise fatal illnesses.
Yeah. Okay, so let's back up just a little bit. You mentioned Don Thomas. He's the protagonist of this story of yours. Who was Don Thomas?
So Don was a guy that grew up dirt poor in Texas. His dad was a solo practitioner, but back then that didn't make a lot of money. But Don was entranced with what his dad did and always wanted to become a physician. He didn't have enough money to go to medical school, and so he started working after graduating from college as working for his PhD. But then because of World War II, there was this acute shortage of physicians, and suddenly we needed more physicians to be trained because so many docs were going into the Army. And so they started providing scholarships where he could get into medical school, and he eventually got into Harvard and graduated from Harvard. After he graduated from medical school, he had this idea about marrow transplantation from reading a few early papers, and that's what he pursued, this incredibly novel idea of the possibility of developing marrow transplantation as a cure.
Now, of course, we think of him today as the pioneer of bone marrow transplantation. There were a lot of steps that had to be taken along the way for him to achieve that. Can you talk a little bit about some of the essential preconditions that were in place, or some of the early work that Don looked at and that informed his thinking and led him down this path?
So much of it actually came from the number of deaths from the atomic bomb blasts in Hiroshima and Nagasaki. When those bombs exploded, there were totally about 200,000 people that were killed. About 80% of them were killed because of the percussion and heat of the blasts. But another 20% or so died delayed deaths, and they died because of radiation toxicity. The radiation from the bomb had destroyed their bone marrow, and so they died with aplasia. That is, no red cells or white cells or platelets. So weeks to months after the bombing, they died with bleeding and infections. After the war, a number of people were doing investigations into that, thinking this might not be the last atomic bomb that's dropped, or there's certainly going to be potential, disasters at energy performance when people are trying to develop nuclear energy. And one of the key experiments was the so-called spleen shielding experiment, where mice were given radiation and they died with the same kind of aplasia that happened to the victims of the atomic bomb blast. But if their spleens were shielded or their bone marrow were shielded, the mice recovered. And then the next iteration of that experiment was to take bone marrow or spleen cells from a genetically identical mouse and infuse it into the radiated mouse. Instead of just shielding the spleen, they actually took cells from a normal mouse and infused them, and again, those mice recovered. Well, Don Thomas read those initial experiments that were done in the late 1940s, early 1950s, and he reasoned that if you could destroy a normal bone marrow and replace it, why couldn't you destroy an abnormal bone marrow and replace it? And that's when he started pursuing this idea of marrow transplantation. Of course, genetically identical inbred mice are a lot different from the outbred species that we are.
So he thought, what if we could transplant marrow in people for people with various leukemias, blood disorders? But this was not done. What were some of the obstacles that he was up against, the doubts?
Well, remember, Luke, in the 1950s when he was first thinking about this, we didn't know anything about HLA. The three letters HLA were never, given in that order at the time. The idea of histocompatibility and how to do that between humans was totally unknown. And in fact,
Matching.
yeah, matching. And I mean, for thousands of years, literally thousands of years, people had thought about transplanting body parts. Could you give new nose or new skin or a new ear to someone? And it would never work. Those tissues would always get rejected. And so when Don first was thinking about this, there was universal skepticism. It was thought to be like gravity. You couldn't transplant tissue between non-identical twins. It was just against the law of nature. But there were a couple experiments that made Don think that maybe that wasn't the case, that maybe you could affect the immune system so that you could get allogeneic tissue to engraft.
Mm-hmm, mm-hmm. Now, when did you first become aware of this work? Was this the early 70s?
Yeah, so I was a sophomore in medical school in 1970, and there was a wonderful teacher there, Dr. Jane DeForge, who was one of the early, really wonderful hematologists. And she was, just serendipitously, I was assigned her as my clinical mentor. And so during the second year medical school, she would take us, a group of us around and teach us how to do a physical examination and how to work up a patient. And then she would take us around the wards, and so we could see different signs of diseases. And, there'd be a patient there who had they could have jaundice, and you could see the yellow eyes, or would have ascites, and so you'd palpate their belly. And one of the patients that she was taking us around to had leukemia, and we were learning how to palpate an enlarged spleen. And when she was teaching us this, she happened to mention that there was this article that had just been published in 1970 by Don Thomas about the possibility of bone marrow transplantation. Now, the patient didn't survive that, but it showed that the marrow at least could engraft. And I just thought that was so amazing that afternoon after she told us about that, I went to the library and was reading through different journals and read that article. And I don't know why, Luke, but it was like having my brain tattooed. I just said, wow, that is amazing. And that idea never left me.
So did you call him, meet him? What happened next?
Oh, well, I was only a sophomore in medical school. I don't think Don Thomas was going to talk to me at that time. So I finished medical school and then did internship and residency. But when I was in my last year of medical school, I learned about the National Cancer Institute and the potential for doing a fellowship there. And that was very entrancing for a number of reasons. Number one, it was one of the few places that really had fellowships for people in training to be oncologists. It wasn't a field back then, or just beginning to be a field. And secondly, it actually satisfied your military requirement if you were in the public health service. So it was a pretty nice position to get.
Vietnam War era.
Yeah, exactly. Mm-hmm. The so-called Yellow Berets, as you know.
Yes.
And so I applied, and luckily I was accepted in a position there. And when I finished my internship and residency, I went to the NCI and was interested in doing work in transplantation biology. And so when I was there, I actually got involved in some laboratory work, which Don Thomas happened to notice, and one day called me up and asked if I was interested in coming out to Seattle and working with him.
So Don had moved to Seattle. What year was this?
So Don started his work in thinking about the idea of doing transplants when he was still at Harvard. But they didn't have much interest in that. In fact, Don was looking for space to try and do some initial work in the mid-1950s, and space was not forthcoming. And so he moved.
Space is in lab space.
Space is in lab space, and the possibility of doing any kind of experiment.
Now, was there active opposition to this idea that this was just crazy Wild West medicine, because so many things could potentially go wrong?
Absolutely. So actually, the guy that was Don's boss at the time was Sidney Farber, who was, who was famous for having developed the first chemotherapy for leukemia. But after he did that kind of work, Farber got very conservative, and at least according to the people that I interviewed, wanted nothing to do with Don's idea, saying that it was just crazy, and he wasn't going to be part of it. And he was not going to give Don Thomas any space to pursue his laboratory ideas. So that was in 1955, and with space not forthcoming, Don decided that he was going to do those experiments no matter what. And so he moved to Cooperstown, New York, to work there at the Imogene Bassett Hospital. Now, the reason he moved to Cooperstown was that there was someone he had already met at Harvard by the name of Joe Farabee. And Farabee also had this idea that maybe marrow transplantation would be possible. And Thomas and Farabee hit it off. And so he moved to Cooperstown and started his first experiments then in 1956.
There were fewer naysayers around.
I think the vast majority of people would have said, this is crazy.
But they weren't entirely off base or wrong to think such a thing. I mean, after all, the Hippocratic Oath says, first do no harm. And there was plenty of potential for harm, and sometimes there actually was.
Yeah, but doing nothing in a fatal disease can also be harmful. And so there's a balance there. As I mentioned in my book, Hippocrates said, first do no harm, but Shakespeare, wrote, diseases desperate are by desperate appliance cured or not at all. And so, that's a hard balance.
Don sided more with the Shakespeare saying.
No question about that, Luke.
Okay, so years go by. What were some of the main achievements or glimmers of success in those early years, maybe in the animal models or some of the early clinical work that gave him the confidence to keep going, that maybe he was onto something? So he first tried to do marrow transplants in humans in around 1956. And he treated 6 patients who they were absolutely at death's door. And really the only question he wanted to know is, could you give bone marrow intravenously? Or if you took bone marrow out and gave it intravenously, would it all just get clogged up in the lungs? Because that's the first place these cells are going to go. And could they possibly get a graft? Well, that experiment failed miserably. I mean, none of the patients survived. They all died fairly quickly. You could give the bone marrow intravenously without acute toxicity, so he did show that. And there was possibly temporary engraftment in one of the 6 patients, but it was really minimal, hardly at all. And so Don realized he had to go back to the animal model, that this was really going to be a very, very difficult problem to try and solve. And so he started working, and he used canine model. He used dogs because, unlike inbred mice, dogs are outbred, and they come in litters, which are like families. And so you could possibly figure out how to pick a donor which might be compatible. But he kept working in humans as well, but really pretty much focused his work on patients who had identical twins. And in the late 1950s, around 1958, he transplanted a couple young children who had really overt leukemia right at the end stage of their life, who happened to have identical twins. And he treated them with high doses of radiation and then an infusion of bone marrow from their identical twins. And the patients did get temporary engraftment. The leukemia went away. They recovered their counts. The radiation doses, nobody would have expected anyone to recover from those radiation doses without the bone marrow support. He'd already shown that in animal models. Very high dose radiation, which whacked the cancer,
absolutely,
leaving not much left. And then you infuse the marrow, and it engrafts, as you say, which means gets into the bones and begins populating all those red blood cells, those white blood cells, the immune cells, everything you need for life.
Exactly. And that was, now the leukemia came back, and it came back fairly quickly because there was so much leukemia when these young kids were being treated. But the fact that the leukemia went away, there was a temporary remission, and the new bone marrow from the normal twin engrafted was, it was a major step forward, and it was very encouraging for Don. But they still failed when they tried it between individuals who did not have identical twins, because they didn't know how to select. There was no knowledge about HLA at that time. Then about 2 years later, he was actually the guy that he was his fellowship instructor in Boston was a guy by the name of Clem Finch, who was became quite well known as one of the hematology leaders in iron metabolism. Clem had left Boston, had moved to Seattle. And so he invited Don out in 1960 to give a talk in Seattle. And Don came to give the talk, and he was talking about, transplantation just wasn't working. You get brief remissions in some of these kids that had end-stage leukemia and identical twins. And if you tried it in people who didn't have identical twins, the graft would get rejected, or they would cause something called graft versus host disease. As he's finishing his talk, a young fellow comes running up and says, "I think I have the identical patient for you." And Don says, "What?" And he says, "Well, I have a 6-year-old girl who has aplastic anemia. And she's dying of aplastic anemia." Now, aplastic anemia is a disease where the bone marrow just fails. There's not a malignant cell to get rid of. The bone marrow just fails. But she also had an identical twin. And so Don raises his eyebrows. And now it was a different era then. So Don's a visitor. He doesn't have a medical license to practice medicine in the state of Washington. He certainly doesn't have hospital privileges. But he and this fellow take the normal identical twin into the operating room, remove bone marrow, infuse it into the patient, Nancy Lowry, and 2 weeks later, Nancy's counts are recovering, and 2 months later, she's back in school. Can't tell her from her normal identical twin. That was in 1960, 63 years ago, and Nancy Lowry is still alive and well.
Wow.
Now, living nearby, and her identical twin, the normal donor, is also fine. So she was the first person ever cured with a bone marrow transplant on the face of the earth.
And that was a single infusion.
Single infusion of bone marrow from a normal donor into an identical twin whose marrow had failed.
Now, was that recognized at the time as a medical breakthrough and something that ought to be followed through in 1,000 different ways?
It was recognized by some people, and so individuals started trying transplants. Other people beside Don started trying transplants, but without knowledge of how to pick a donor, except in the very, very rare circumstance of aplastic anemia with an identical twin, everyone failed. And it's estimated that there were maybe 160 to 170 transplants performed between 1960 and 1966. Every one of those patients died.
Wow.
And almost everyone was leaving the field because they just didn't know how to make it work.
Now, this makes me wonder about Don as a character. Like, what is it about this person that allows him to keep going? Now, he had a glimmer of success, a little bit of validation against a whole lot of failure.
Yeah.
You knew him. I mean, what was it about his makeup that allowed him to persist?
I don't know, Luke. I don't. I mean, he was incredibly focused. He believed that the benefit that could come from transplantation, if he could make it work, was so enormous. In his own words, he said, I feel like I owe it to our patients to try and make this work. And he said, that if he ever got to a real dead end, he would have probably found something else to do. But he never got to a real dead end. There was always another experiment to perform, another avenue to pursue, another thing to try. And along the way, he was making progress in the animal model. While there was all this failure in humans. And by the way, most of that was other people trying it without knowledge of how to do histocompatibility typing. Don really had given up most of his clinical attempts, except in identical twins, while he was working in the animal model. Around the early to mid 1960s, around 1962 or 3, he started finding out that if he did transplants between canine littermates, and he gave the right dose of radiation, and then an infusion from a littermate, and then afterwards gave some immune suppression, that while most of the dogs either rejected their graft or developed something called graft versus host disease, where the new immune system reacted against the host, that those animals would die. But there was maybe 1 out of 4, 1 out of 5 of these dogs that would actually engraft and go on to be long-term healthy chimeras, with 2 to 3 years later being tolerant of donor skin grafts and showing that their marrow was clearly from the donor. Now, the challenge then was, how do you select which is the right donor-recipient pairs? But the progress he made showing that sometimes it worked was the kind of thing that kept him going.
Mm-hmm, mm-hmm. And immunology as a science was still very much in its infancy. This idea of histocompatibility, a whole lot needed to be worked out, and then was incorporated by people practicing in the clinic.
Yeah. So during the early 60s, that's when the idea of histocompatibility really was not just Don. There was a whole bevy of individuals who were making some progress there, starting with Dosset and Snell and others. And so Don was reading that and seeing that this was progressing, so that he got to the point by the late 1960s where he could develop typing like HLA typing, but in dogs, so that he could then get to the point where he could reliably identify the right donor-recipient pair. And once he got to that stage where he could find donor-recipient dogs, the right dose of radiation to prepare them for the transplant, the infusion of the bone marrow from the right donor and the right amount of immune suppression afterwards, and every one of the dogs then turned out to be a long-term survivor, then Don felt he was really ready to go back into the clinic and start treating patients. And that's when he did that experiment in 1970, which is the paper that I read that really got me going on it and was sort of the beginning of the allogeneic era.
So a whole lot of science is going on. Well, in the back of his mind, he knew all about Nancy Lowry and the potential here. Keep his eye on the prize, work out some of these, work through some of these obstacles of the immune system. So he kept at it. Came out to Seattle. When was this?
So he moved out in Seattle in 1965 and was completing the canine work. And there were several people that were working with him, Bob Epstein and Rainer Storb, who were really key to some of that early canine work. But then in about 1969, he wrote the first grant to start doing the transplants in humans and opened the clinic, which was at the Public Health Hospital, what is now the Pacific Tower.
If you like listening to The Long Run, you'll love a subscription to Timmerman Report. This is where you can read my in-depth reports on the most interesting startups in biotech, my regular Friday Front Points column that concisely covers the issues of the week, plus insightful coverage of current topics in biotech from a rotating cast of contributing writers. Individual subscriptions are available on a monthly, quarterly, or annual basis. Group subscriptions provide a license to companies who have more than one reader. Go to timmermanreport.com and click on subscribe for more. And for sponsorship opportunities on this podcast, or to inquire about bringing me to your company for a speaking engagement, see my business development representative, Stephanie Barnes. Go to timmermanreport.com and hit contact. Now, without going into full Chamber of Commerce mode, which I think you and I could probably both do, was there something about the environment, the time and place of being in Seattle, not Harvard, something about the willingness to try new things maybe, or just fewer people around to object, but with a culture of scientific excellence. What was it about this place that milieu that he was able to operate within?
So Don was given space in the Pacific Tower, the public health hospital then, and Don knew how sick his patients were and were going to become. Now, these are patients who have end-stage leukemia, so they are on death's door before they start treatment. Then you have to give them very intensive radiation therapy. They're going to get even sicker. And so if Don was going to do this experiment, he felt that he had to be able to control every aspect of those patients' care. And I mean every aspect, from the custodians who were cleaning the unit to the dietitians who were preparing their food. And so he created his own small little hospital, his own little department of medicine.
A fiefdom.
Yeah, you can say that, yeah. Everyone in that little world worked for Don for that one purpose of trying to make marrow transplantation work. You weren't sitting in the middle of a big hospital where you had other, conflicting goals. Everything Don was doing there was to make transplantation work. And so he really did hire his own nurses, his own dietitian, his own social worker, his own pharmacologist, and his own docs to work for him. And there was just something about Don that there was, you talk about teamwork in baseball or in basketball, where everyone is working well together and the whole is much bigger than the sum of the parts. And Don was a great team leader. He had just a personality that people that came, they wanted to work with him. They wanted to see if they could contribute to make this work. And Don was incredibly generous. Whenever he would give a talk, he would always credit all the other people who were contributing.
How long did it take before this went, I guess you could say, mainstream?
So Don's first 2 years, the first 18 patients in a row died. So it took, again, that kind of perseverance. But then there were a couple survivors within the second year. In 1974, the transplant group had done over 120 transplants and published a two-part article in the New England Journal that really introduced the concept of marrow transplantation, I think, to the rest of the medical community. Among the aplastic anemia patients, not twins, but these are getting transplants from donors, matched sibling donors, the cure rates were now over 50%, which was very encouraging, given that otherwise it was a death sentence at the time. Among leukemia, these are end-stage leukemia patients, the cure rates were low. They were in the 15% to 20% range, but they were cures. These were people now that were 4 or 5 years out. Otherwise, they would have been dead within a month or two. And so by 1975, there was some growing encouragement that this was a real therapy. Once Don showed that you could cure patients who had end-stage leukemia, then the process was to take it earlier in the course of disease, in second remission or first remission. At the time, for AML, which is the disease that I spent most of my career pursuing, chemotherapy worked, but it only worked 15% of the time. Don could show that end-stage leukemia patients could be cured maybe 10 to 15% of the time. So the question was, if you took these patients who were in first remission and transplanted them, could you increase the cure rates? Now, it was a gamble because transplantation at the time still was incredibly brutal. There was probably a 30% chance that you would die of the procedure, not of the leukemia, of the procedure.
Right.
And so you're asking a patient who has maybe a 1 in 8 chance of already being cured to take on a therapy which has a 1 in 3 chance of killing them. And we don't know if we're going to improve on the 1 in 8 cure rate. Hopefully we would, but we didn't know that.
The odds aren't great.
But the patients were willing to try because 1 in 8 didn't sound great either. And of course, not every patient was willing to take the gamble, but a group did. And with the first 19 or so patients, the cure rates looked like they were going to be 50% or better, showing that it probably was a worthwhile gamble. And that's when transplantation, I think, at that point started to come into the mainstream. Sort of by the mid to late 1970s, people were starting to transplant patients in first remission for AML and starting to do it in other hematologic malignancies like CML and ALL, et cetera.
Practices improved on reducing the rate of rejection and graft versus host. There were a lot of parameters that you could have some control over to reduce those numbers and improve the overall odds.
Absolutely. And one of the biggest ones actually was development of methods to prevent infection. When we started doing transplants, there was about a 7% fatality rate from pneumocystis. Among the patients, about 50% of them had CMV within their body, like most of us do. But of those, because they got so immune suppressed during the transplant, about half of them, 25% would develop CMV disease, and half of them would die of it. So we had 7% deaths from pneumocystis, 12% deaths from CMV. There was fungal disease that was causing lots of deaths. And so that was a major problem. But Don created his own little team of physicians, and some of the heroes there were Joel Myers and others who developed methods to prevent CMV and prevent pneumocystis. And so it was many of the other related little steps that allowed transplantation to become better and better.
So there's a story of incrementalism here. There's like the big idea, the central insight, and then there's a whole lot of grinding through incremental improvements.
Absolutely, Luke. There's a great quote from Il Doctoro that I like a lot, where he says that it's like driving at night through the fog. You can only see as far as your headlights, but you can make the whole trip that way.
So you sought to write a book about this after living much of this story. You came out here in 1975, and a lot of this is where the action was. Things were happening. You were a part of this. What compelled you to want to write a book about it?
Well, mostly I felt like I needed to write something that commemorated Don, the team, the patients that made it all happen. If nobody had written the story and it was just lost to history, I thought that would be just a tragedy. And so mostly it was to commemorate Don and not Don himself. Certainly he was a huge part of it, but all the other people that worked with him, the nurses. The nurses were unbelievable, Luke. We're talking about a group of individuals who were there at the patient's bedside. As a physician, you go in and you talk to a patient and you examine them and you develop a close relationship to them. But it's nothing like the nurse who was there at the bedside, 8 hours a day with these patients, nursing through these against horrendous odds. And just imagine that they're sticking this out when they know that 8 out of 10 of their patients are going to die. They're an amazing group of individuals.
And many of them are still alive, and you were able to go back and speak with, interview them?
Absolutely. When COVID hit, and we needed people to come in and give the shots to people that were getting the first vaccines. Almost all of them were our old transplant nurses who were retired that volunteered to come back in and immunize the staff and patients and faculty. I think it was so great to see them. They're really very special people.
That's pretty inspiring.
It is. Now, the other thing that I know that, look, no book is going to have a measurable effect. It's a big world, right? But any little thing, I think that in this day and age, we can do it. And Luke, you do it as well as anyone that contributes to increasing scientific literacy in this day and age, I think is doing what they can to help the world.
Well, this is a story of medical history. It's also a biography, but it's more like, you have a central character who is guiding us through this history-making event. And I think your title kind of sums it up, Living Medicine. When most people think about medicine, they think about a tablet in a bottle or a liquid in a vial that you stick in the fridge, pull out of the fridge maybe, but this idea that cells, the fundamental unit of life, can be coaxed, engineered in such a way as to become the medicine itself. That's a whole different thing that Don Thomas was at the tip of the spear of. And now you can see it happening in all kinds of ways. So this informed your thinking, like there's a story here to be told that's important.
Absolutely. Now, I'm not a CEO of a biotech company, and one could argue whether there's more future in small molecules or more future in cellular therapy. Certainly, it's going to be both. I think we would agree to that. Mm-hmm. But that was another. It was just, if you look at what's now, I'm prejudiced. I'm biased. There's no question about that. But at least through the lens of the world that I see, when we look at the revolution that's happening now in three really different areas of medicine, you can draw a direct line from Don Thomas and transplantation. First, there's gene therapy of like sickle cell anemia and thalassemia, where instead of doing the transplant of bone marrow from a normal individual to a patient with sickle cell, by the way, the first person ever cured of sickle cell anemia was a young woman, Kimberlyn George, who happened to have leukemia, but also had sickle cell disease. And in doing that transplant, she was cured of both. The first person ever cured on the face of the earth of sickle cell. And now what we're thinking about is still it's marrow transplantation, but instead we're going to take the marrow out and we are repairing the gene defect and doing an autologous transplant. And someday we'll be able to, as you know, instead of taking the marrow out, we'll be able to just infuse the vector and cure the disease in vivo. But you could say that started with marrow transplantation. So the whole revolution in gene therapy, you can trace back to what Don did. The whole revolution in adoptive T-cell therapy, the new CAR T cells and TCRs. Don was the first to show that the human immune system could eradicate disseminated leukemia. He showed that the relapse rates after transplantation were far higher after identical twin transplants than they were after allogeneic transplants. And if you took the T cells out of the allogeneic marrow, the relapse rates went right back up to what they were with identical twins, showing that it was the T cells that were seeing the leukemia in the patient as foreign and rejecting it. Well, then we took the next step with Phil Greenberg and Stan Riddell of finding out, could you find the cells in the donor that were seeing the leukemia as foreign, and can you clone them, and can you grow them to larger numbers? And now, instead of trying to take them out of the patient, we're taking them out of the out of the donor, we're taking them out of the patient and putting the receptors in. So the revolution in gene therapy, the revolution in cell therapy as adoptive cell therapy for leukemia. And finally, Don was the first person who ever transplanted any kind of stem cell. And now that they were doing, whether it be islet cells for diabetes or muscle stem cells for muscular dystrophy. I mean, these three revolutions that are happening right now, you can draw a direct line from Don Thomas's pioneering work.
This whole other next generation of scientists and entrepreneurs looked at that work and wondered about what else might be possible. And whether it was Steve Rosenberg, Carl June, Phil Greenberg, all these people, they saw what T cells could do. That they had this ability to hunt down the malignant cells and they have memory. You can do like this in one infusion. And with patients who are on death's door that come back and live, it was instructive and inspirational, and they built on it.
Yeah, I believe that. I think that it certainly was a motivating factor for. And now each of these people are heroes in their own regard, and I don't mean to diminish what they accomplished in any sense, but I think that Don was foundational for that developing, and the fact that these cells not just do their job, but they continue to live in the patient for the rest of their lives is just it's extraordinary.
Yeah. Back to this bit about writing the book. Writing a book is hard. How did you get motivated to do this or inspired? Were there some authors you talked to or other books you read that you found helpful?
Who's that guy that wrote the book Hood? I don't remember who that was. Maybe that was it. No.
I speak from experience. Writing a book is hard.
This wasn't hard. I have to say it was a consuming, but it wasn't hard. I mean, I loved doing the research before. That was probably so entertaining to read through some of the. Well, I did read a lot of other books about immunology, and I thought I knew a lot about it, but that was fun. Also, reading some of the original articles where I thought I've been doing transplants for 50 years. I thought I knew everything about it. And not only were the stuff that I didn't know in the history of immunology, which was really fun to read and instructive, but there were things I thought I knew that I was wrong. People had quoted an article, but they had quoted it wrong. And only when I went back and read the original article did I realize that people had been interpreting that data incorrectly. And that was really fascinating to go back. Having the opportunity to interview a lot of the people that were involved from the early days. I took a trip to Cooperstown to see where Don lived. That was a lot of fun, and also got to visit the Hall of Fame, which was not bad. In fact,
nice side trip.
Nice side, and I gave a lecture there, so they paid for it. It was even better.
Oh wow!
So that was a lot of fun doing the research and reading a lot of Don's correspondence. So
you got to mine some of his private letters and documents.
First of all, the Hutch did a great job of archiving a lot of Don's initial early letters, papers, interviews, and I have to also thank his 3 kids. They were wonderful in helping with this, and some of the other members of the Hutchinson family gave me a lot of really amazing primary material, which was just a lot of fun.
So there's a lot of primary research that you did and rereading of the literature at the time to synthesize a new thing. But then there's also the matter of writing it in an accessible way for a variety of different audiences. A lot of medical writing can be pretty dry and clinical and written for your peers. And I'm sure you've written lots of those peer-reviewed articles. How did you practice writing in a way that, as Sid Mukherjee says, sparkles? I mean, you really write in a visual and evocative way that I think your average patient or curious person browsing in a bookstore can read this and understand it and appreciate it.
Well, thank you. I appreciate that you feel that way. That does mean a lot to me that you do. 2 things. The first is that I've been practicing medicine and particularly treatment of leukemia and transplantation for a lot of years. And this is my own bias, but I have found, and again, I'm biased, I'm an N of 1. I have found that one of the things that relieves patients' anxiety more than anything else is understanding what's going on. That you can't make the disease go away, and you can't make the therapy less toxic and less risky than it is. But if patients understand a little bit more about the disease, that it isn't something that they caused because they, did something wrong. And they understand why you're using certain drugs, and so they know that there's going to be toxicity, but why isn't there a drug that, why is there toxicity, and can they understand that? That if they can understand what they're going through, it just is less anxiety provoking for them and their family members. And so I've kind of practiced explaining this to patients over the years, and I think that helps. That helped me in how I explain things in the book about, what is, how does the immune system work, and how can you possibly ever get tolerance? How's that even conceivable? And then, I did have a number of people that I read and enjoyed and gave me some advice. A good friend of mine, Jerry Groupman, I talked with, and a couple others. And one of the things they said is, it's
a physician who writes for the New Yorker or used to.
Right. Yeah. Mm-hmm. Yeah. Your writing has to be cinematic to a certain extent. You can't just keep in a single plane. You have to sort of explain things, but then you have to have a scene. That's something that happens. And then you can go ahead and explain a little bit more, but then you need another scene. Now, one of the things that I struggled with a little bit is how to continue to put in enough scientific explanation along the way that the reader wouldn't get lost. And so at some point I had to sort of stop a little bit and explain just the basics of hematopoiesis, how does blood form. Mm-hmm. Then I could go a little bit further. Then I had to explain a little bit about histocompatibility and what was Don up against. Then, go a little bit further, and then you could explain a little bit more about how the immune system works and how it can possibly attack leukemia. So you have to intersperse the narrative with a certain exposition, and then, a few scenes, and keep doing that. And
there's some science, but it's not a textbook. And in between, you've got characters like Don and his wife Dottie and their dogs. And they like to go hunting in the Pacific Northwest. And these are characters that from Texas people can relate to.
Yeah. And that's what I have to say that writing the book was one of the most all-consuming things. I would wake up thinking about it. I would, be doing it in the day, during the afternoon, in the evening, and when I was exercising, I'd be thinking about how to organize it, and it was the last thing I was thinking about as I was falling asleep at night. It was very consuming. I'm sure you've gone through that.
Yeah, a very immersive process. Okay, so the book's been out for a little while, a couple months. What sort of feedback have you gotten from various types of readers?
Well, I'm not sure I would have heard if people didn't like it. I don't think they would have called me up and said that. But people have generally been really, really positive, including colleagues which are in the transplant field. A lot of them have called me up and wanted signed copies and wanted me to sign multiple copies for them, which is really nice that they have enjoyed it. And then I've gotten some very nice comments from patients that I've actually treated decades ago that thanked me for doing it and wanted signed copies. So it's been very nice. Been very gratifying, and the reviews that are out there from in the ASCO Post and the Cancer Letter have been also pretty positive.
You think you'll write another book?
I might, but it'd have to be the right topic, Luke. I'd have to feel as passionate about that one as I did about this one. But there are stories. There are some amazing stories that have come from the Hutch and from the world of science that I think people would benefit from knowing. We're only going to we will make better headway in the world of science and research if we have a more informed public that's willing to support it. None of this comes for free. We need public support. We need funding from the NIH and from the NCI. We need philanthropy. We need, it's not going to come from nowhere. And the more people that understand the process and understand what's what's happened and what the potential is, I think the better off we'll be. So if I write another book, it's going to be in that vein.
Well, a book agent once told me that when you're embarking on a project, you should start with a few simple questions. Is there a story to be told here?
Right.
Has it already been told? And am I really singularly positioned to be the person to tell that story? And reading your book, I think, well, clearly you've been a participant in this revolution, so you're very well positioned. There certainly is a story that hadn't been told before, and I think it's really quite valuable for everybody, students, patients, people in this industry, to learn about the beginnings of the cell therapy revolution.
Well, I appreciate your feeling that way, Luke, and hopefully others will as well.
Fred Appelbaum, thank you so much for joining me on The Long Run.
Thank you for having me.
Thanks for listening to The Long Run, a production of Timmerman Report. Pedro Rosado of Headstepper Media was the sound editor. Music is from D.A. Wallach. See you next episode.